Good morning, everybody. Welcome to another exciting morning, and unfortunately, our last morning together with Chem 1211 with your host, me, Dr. White. Oh, I got to do this. Love it. But, anyways, important information or announcements. One, this morning I sent out an email telling everybody that as of 7:30 this morning, I have graded all tests and labs, anything you handed in, and posted it in Blackboard. If you're missing a lab or anything else, make sure it's sent to me by email, except for the lab done today. I haven't graded the last lab yet, but up through lab 12, send to me as an email. The deadline is Saturday, 1 p.m. That's Dr. White's being nice because in the normal semester, after 1 week, you get a zero. But uh, unfortunately, we're not all together, and I got my back problem, which messed my timing up. So that's why I'm doing this and allowing you to hand things in late. All right, next week, Tuesday at 10, we have no classes whatsoever next week. Next week, I will have my office hour. If you need any help, email me because I'm on Zoom whenever I want to be. If you really need it, I'll see if I can set some time aside for you besides my office hour. Don't tell anybody I'm being nice. But anyways, that next Tuesday, a little before 10 o'clock a.m., I will send out the password in an email to you, like I've done for the test, and you'll have until the next day. I think it's either 10 or 12 p.m. to get it in. You have to be on time because next week I'm going to be swamped with things that I have schedules I have to keep. Therefore, as in my email I already or announcement I sent to you, if you're late, I reserve the right to say 50 up to 50 points from your score. That won't be good. All right. Don't forget to hand in today's lab. All right, let's get going. I'm going to continue with the review we were doing. I can find, here it is. All right, let's continue. Did everybody see chemical bonds on your screen? Thank you. All right, remember, you should know ionic bond, what it is. It results from the transfer of one or more electrons from one atom or group of atoms to another atom or group of atoms. Next, what is a covalent bond? You should know. Remember, I put those on test number 2, hint. And a covalent bond results from, and this is important, the sharing of one or more pairs of electrons between atoms. I talked about the octet rule, and that's because all atoms want to have 8 valence electrons. I'll never ask on the final, what's the octet rule? Now, elements can form ions, and they can either lose or gain electrons to have the same number of electrons as the nearest noble gas. And we went through this for test number 2. You had it. And let's look at calcium. Remember, the atomic number is number of electrons and protons. Calcium has 20 and 20 electrons and protons. The nearest noble gas is argon, which has 18 electrons, but it will never lose protons. Each electron is a -1 charge. Each proton is a +1. Do the math. -18 plus 20, that's a +2. How do you write the ion for what ion calcium forms? You write it like this or like this. Either one would be correct. Now, next one, how do you determine the formula of an ionic compound? The number and the kind of indicates the number of ions and the type, how many. Remember, and this is important, the sum of ionic charges in the formula is always 0. All right, let's get moving. So if I were to ask you, write the formula for an ion or molecule that has calcium +2 and nitrate -1, how do you do that? This is a +2, this is a -1. Does this add up to 0? No. You can't change the charge, but you can change how many. And if I had 2 of those, now it adds up to 0. How do we write that? 1 calcium. But notice here we have a polyatomic ion, and therefore you have to, if you have more than 1, you have to put it in a bracket. And how many do I need? 2 subscript 2. And why don't you have some fun? I'm going to share what would be the formula for a molecule that has sodium plus and sulfate -2 ions in it. Next semester, I'll be teaching a VCM as opposed to true internet course, and I'm going to take attendance. But then they know it's a VCM course, but I'll still post my videos. So if you ever want to see what I'm doing next semester, come back to Chem 1211 YouTube channel, and you can see me once again being a wild and crazy guy. All right, I'll give you another 8.27 seconds. I think my clock is running slow. Time's up. All right, how do you do this? You have what charge on sodium? +1. What's on the sulfate? -2. Does it add up to 0? Because all molecules have a net 0 charge. And the answer is no. How do you do that? You need 2 sodium. How do you show that? And 1 sulfate. When there's only 1 polyatomic ion, you do not have to put it in a bracket. Next, I showed you how to draw the Lewis structures for molecular compounds. Remember, bonded electrons, and I don't think I'll ever ask that on a final, are pairs of valence electrons that are shared between atoms in a covalent bond. Non-bonding are pairs of valence electrons that are not involved in electron sharing. For those of you watching the video or here live, I don't usually put that on a final. Or would I give that away? All right, something you should know, important, real important, and that is the covalent bonds. You should know a single bond, a bond between 2 atoms which share 1 pair of electrons. In other words, a single bond, 1 pair of electrons shared. Double bond, 2 pair of electrons being shared. Triple bond, 3 pairs of electrons being shared. And if I asked you to draw the Lewis structure, for this compound, chlorine. How do you do that? First of all, you have to look up and look at the top of the periodic table. Chlorine has 7 valence electrons. So I have 7 there. Second one, 7 there. Notice one unpaired, and therefore they pair to form a single bond. The non-bonding electrons are still there. That's supposed to be an L. Now, if we look at sodium hydroxide, whenever you see an alkali metal, it always forms a cation, and the cation is a +1. Remember, sodium has 1 valence electron, oxygen 6 valence, and hydrogen 1. Dr. White uses this a lot, so he knows in by heart, but you look at the top of the column in the periodic table. Well, oxygen has 6. Remember, 1 on each side before you double up. Hydrogen has 1, and oxygen has 1, so they form a bond right there. And they form a bond. What I needed to do was, and this is a single bond. Now, if we look at hydrogen, is the one exception. It has 2 valence electrons. Shared electrons are counted as valence electrons. But if we look at our hydrogen has 2 valence electrons, and this octet is 2. Oxygen has 2, 4, 2, 4, 6, 7. Oh, it's supposed to have 8. Where did it get? What happened? Well, where did this valence electron go to make the cation? It goes over here, and now since this has an extra electron, you have a minus charge on that. And I did that on test number 2, and most of you got that wrong. I'd highly recommend you go back and look at that. Aren't you glad of the benefits of having a review with Dr. White? All right, next I talked about a mole. You should know a mole is a chemist counting unit. And 1 mole of an element equals Avogadro's number. Avogadro's number, even though I don't have it written correctly on that page, is 6.02 times 10 to the 23rd. 23rd should be superscript, and it should look like this. Avogadro's number, which I asked on test number 2, is this. And that's the chemist counting unit. And as you learn, 1 mole of an element equals Avogadro's number in atoms of that element. 1 mole of a compound equals Avogadro's number of molecules of that compound. 1 mole of an element equals the atomic weight of that element in grams. And 1 mole of a compound equals the molecular weight of a compound in grams. By the way, the molecular weight of a compound is the sum of all atomic weights. This will be given to you in important information for the final exam, the last 2 pages. I would highly recommend that you go to Blackboard and you'll see a file in the lecture section called Important Information Final Exam. And those are things you don't have to memorize, but you do know how to use. And don't forget, your good buddy, oh, I ran out of breath, and your good friend, unit analysis. Just think how crazy I am. No. I'm not. I'm saying right. All right. Let's go through a couple real quick. Wrong one. Right one. Everybody see how many moles? Hold on. You guys see it? Thank you. All right, let's look at this one. How many moles are so many atoms of silver? You're trying to find moles. You're given atoms. This is what you're starting with. You're trying to get the moles of silver. Unit analysis tells you whatever you're trying to get to goes on top of that ratio. Whatever you're trying to get rid of goes underneath. And therefore, when we do the math, notice this is 4 significant figures. 1 in here is an exact number. Avogadro's number is 3 significant. So my answer is 3 significant figures. Now, remember the molecular weight is the sum of all atomic weights, and use on the final, just like my test, it will say, please use all atomic weights to 3 significant figures. I'll also say, please use proper significant figures for all calculated answers. And if we look at what's the molecular weight of H2SO4, sulfuric acid, it's the sum of all atomic weights, 2 hydrogen, 1 sulfur, 4 oxygen. 2 times the 3 significant figures, the atomic weight, which is a number underneath the chemical symbol on the periodic table, is 101. For sulfur, it's 32.1, and for oxygen is 16.0. These are all 3 significant figures. 2, 1, and 4 are exact. Do the multiplication, add it up. Now, remember, when you're doing addition, you get the same number of significant figures to the right of the decimal point as the number you're adding that has the fewest significant figures. So if we look here, 2, 1, 1, that dot there shouldn't be there, 98.12. You round off only to the right. 1 significant figure, keep the 1, look at the 2, is that 4 or less? I drop it. And the correct molecular weight to using 3 significant figures for atomic weights is 98.1. And if we look at problem 16, how many moles are 2.345 grams of ammonia, NH3? We're trying to find moles of NH3. We're given grams of NH3. This is what we start with. We're trying to get the moles of NH3. Whatever you're trying to get to goes on top because you're using your good buddy, your good friend, unit analysis. Whatever you're trying to get rid of goes underneath. Where do you get these numbers? 1 mole equals the molecular weight in grams of ammonia. What's the molecular weight of ammonia? In 3 hydrogen, 1 nitrogen, 3 times 101, 3.03, 1 times 14.0, which is the atomic weight of nitrogen to 3 significant figures. You add it up, you get 17.03. Notice the first number has 2 to the right of the decimal. The second one, only 1. Therefore, your answer should have 1. Keep the 0, use the 3 to round off at 17.0. Notice 4 significant figure, exact number, 3. That's how you get that. And I highly recommend you know how to do that. Hint. Now, talked about chemical reactions. You should know at the base of the arrow, you have your reactants. I call them starting materials because I worked in industry. And at the head of the arrow, you have your products. When you're balancing a chemical equation, you should have the same number and same type of elements on each side of the arrow. You can only change the coefficients. Dr. White's hint to you, or the way I do it, always leave oxygen, hydrogen, or hydrogen, oxygen last. And remember the even odd trick. There'll be at least 4 balanced chemical equations on the final. They're usually 3 or 4. I think there's 4. So make sure you know how to do it. Remember, leave hydrogen, oxygen last. Practice the even odd. And as I've said many times, use your hourly exams as practice problems. So go back to test number 2 and try and see if you can balance those chemical equations. Now, I taught you for mass calculations for reactions, there's a 3-step you have to do. You can't do it in 1 step. And this will be given to you. And you convert mass of A to moles of A. Whatever you're given in grams, you convert to moles. And then whatever you have in moles now of A, you convert to moles of what you're trying to get to, your answer. But your answer is going to be in grams. So the moles of B, you have to convert to mass of B. Remember, the coefficients of a balanced chemical equation are mole ratios. Everybody see problem number 4 on your screen? Thank you. Let me make it larger. And 10 points. Given the following chemical reaction, how many grams of hydrogen are needed to make 125.6 grams of HCl, hydrochloric acid? You're trying to find grams. You're given this weight, but you're given this balanced chemical equation, which tells you 1 mole when there's no number. The coefficient is 1. 1 mole of hydrogen reacts with 1 mole of chlorine to make 2 moles of HCl. 1 mole of hydrogen reacts with 1 mole of chlorine, give you 2 moles of HCl. You need 3 steps. The first step, whatever you're given in grams, you convert to moles using unit analysis. Moles go on top, grams go underneath. Remember, 1 mole equals the molecular weight of a compound. Here's calculation of the molecular weight, and we get this number. Now, second step, you convert whatever you have in moles, HCl, to the moles of what you're trying to get to, hydrogen. And remember, use your good buddy, your good friend, unit analysis. I'm going to wear that out today. And the moles of hydrogen go on top. That's what you're trying to get to. What you're trying to get rid of is moles of HCl go underneath. Where do I get these? From the balanced chemical equation. 1 mole of hydrogen makes 2 moles of HCl. 1 mole of hydrogen makes 2 moles of HCl. And here, if you look, these are exact numbers, always. Coefficients are exact numbers. So 3 exact, and here I have this. Am I done? No. I want to get the grams of hydrogen. I have moles of hydrogen. And this is my 3rd step, moles of whatever you're trying to get to grams. grams goes on top because you're using your good buddy, your good friend unit analysis, and moles go underneath. And 1 mole of hydrogen equals the molecular weight of hydrogen. Molecular weight of hydrogen is 202, and that's how you do it. I highly recommend you go back and check out either test number 2 or your practice problem answers for that and try and do it on yourself. Remember, just don't look at the answers. Try and do some of them yourself because it's like watching the DVD or the Blu-ray. I remember I really spent all the money on you guys. I didn't leave anything out. I got you the Blu-ray, How to Ride a Bicycle. Watching me do it is simple. Trying it on your own, it takes practice. And for limiting reactants, and this will be important information, determine the moles of product produced using moles of each reactant. And then the lower number, you're going to have to do 2 calculations because you'll always have 2 reactants. I could do 3, but that would be cruel and unusual punishment. And so far, it's still outlawed by the United States Supreme Court, cruel and unusual punishment towards students. So I won't do that, just 2. And the lower number of this is what the answer should be. Next, I started talking about gases for test number 3. And this will be given to you important information. 1 millimeter mercury equals 1 torr. And that should be not inches right there. And it's been corrected on the important information of final. I should correct on this one these years. And that's really 760 millimeters or 760 torr. It should be torr in blue, equals 760 millimeters of mercury equal 1 atmosphere. And there, I thought I opened it up. I've opened it up. And let's look at one example. Everybody see how many, problem 3, how many atmospheres is 741 torr? Thank you. What are we trying to find? Atmospheres. What are we given? 741 torr. We have torr. We want to go to atmospheres. Once again, it's time to use your good buddy, your good friend, unit analysis. I am going to wear that out today. And whatever you're trying to get to goes on top. What you're trying to get rid of goes underneath. Where do you get these numbers? 1 atmosphere equals 760 torr. And these are both exact numbers because they're part of a definition. Therefore, this has 3 significant figures. Our answer has 3 significant figures. And no, I wrote it correctly this time. Yay, Dr. White. 760 torr equals 760 millimeters of mercury equal 1 atmosphere, and that's where we get that. Now, I talked about Boyle's law, And Boyle's law is P1 times V1 equals P2 times V2. P1 is the initial pressure, V1 is the initial volume. P2 is the final pressure, V2 is the final volume. And do you see if a balloon on the screen now? Thank you. If a balloon has a pressure of 658 torr and a volume of 1.894 liters, what is the pressure of the balloon if the volume is increased to 5.133 liters? Remember, L liters is a measure of volume. And therefore, we're trying to find the final pressure, P2. We're given the initial pressure, P1, initial volume, V1, and final volume, V2. Now, you're going to do some algebra. Relax. I taught you how to do that. Take a deep breath. You can do it. Actually, I know you can do it because you showed me on the test. And you have P1 equal V1 times P2 V2. You want to solve for P2. How do I get a lone on one side? I have to get rid of V2. Anything divided by itself becomes number one, which means it's gotten rid of or gone. And therefore I divide this side by V2. Whatever you do to one side, you have to do to the other. So I'll divide that. So V2 divided by V2 is 1 times P2 is P2 equal P1 V1 over V2. I'll rewrite it, you don't have to. And now, since I took the time to figure this out, I can put in the numbers. 3 significant figure, 4, 4. Remember, when you multiply and divide, the number that has the fewest significant figures is how many significant figures your answer should be, which is 3. Next, I talked about the ideal gas law, which is Dr. White's favorite mathematical equation in chemistry, not equation, but mathematical, PV equal nRT. And P is pressure, and this is important. It's always in atmospheres. V is volume. That's always in liters. N is the number of moles. T is temperature in Kelvin, and R is the universal gas law constant. And for this class, there are different versions of R depending on the units you use. I'm using atmospheres liter mole K, and that number is 0.0821. And notice this is 3 significant figures. Now, one of the things I asked on test 3, and you should know, everybody see my whiteboard, PV equal nRT? Thank you. Remember, this tells you when to check your car tires in the winter. It gets cold. We'll see how cold with global warming, but it'll get cold in Chicagoland. And therefore, the pressure, the temperature will go down. R and N, unless you have a flat, and then it doesn't matter, but assume you don't, stay constant. V stays constant. So for PV equal to nRT, when the temperature goes down, the pressure has to go down. And we're talking about the pressure in your car tires. In the summer, the temperature goes up, R N and V are constant, and therefore your pressure in your tires will go up. And keep an eye on them if it gets real hot and stays that way for a long time. All right, let's look at number 10. 15 points. If you go back and test 3, you saw I wasn't lying about that. And if you burp 86.75, that's a heck of a burp, 86.75 grams of CO2 gas at 545 millimeters of mercury and 34.6 degrees C, what's the volume of your burp? And here you're trying to find V, and you're given the weight, you're given the pressure, you're given the temperature, and on the first page of important information, you'll be given R. Well, if you notice, you're dealing with a gas and nothing changes. That immediately should tell you this is a PV equal nRT. What are we trying to solve for? V. Get rid of the P by dividing both sides by P. V equals nRTP. Common mistake students make, they don't use the proper units for P and T and N. They put in what I give you. No, you've got to convert them to the right units. And so pressure should be in atmospheres. We're given millimeters of mercury. We want to go to atmospheres, use unit analysis. This goes on top, this goes underneath. Where do you get those numbers? From important information, 1 atmosphere equals 760 millimeters of mercury. 1 and 760 are exact numbers. I do the math, I get in pressure, atmosphere and pressure in atmospheres, 0.717 atmospheres. Temperature has to be in Kelvin. I have never in my life seen a Kelvin thermometer. Centigrade or Celsius, Fahrenheit, yes. Kelvin, no. Therefore, you have to convert temperature to Kelvin, and you have degrees, Kelvin equals degrees C plus 273. And here, this will be given to you important information. Add it up. Here, when you add something, you get the same number of significant figures past the decimal as the number that has the fewest significant figures past the decimal. Here it's 1, but 273 is an exact number. Therefore, you still have 1 in your answer. Finally, N moles. We have grams. You want to go to moles. Moles goes on top. Grams go underneath. 1 mole equals the molecular weight, which is the sum of all atomic weights, in this case for CO2, for exact number 3,3. Put the numbers in. N is 1.97. Here's the universal gas law constant. Here's temperature in Kelvin. And here's the atmosphere, 3, 3, 3, and here, 3. Now, when you're doing these, you don't want to round them off and wait until the end. I calculated both ways. I'm a round off at each step guy, as you figured out by now. But if you're not, I'm not going to force you to do what I do. And that's how you get it. And if I look at the clock, instead of rushing off and doing this and rush, something, I'm going to do it, and we'll come back and we'll take our break a little bit later. I won't forget to give you your break. My body also doesn't forget to tell me it's time to stretch. But let's do this problem one more before our break. What's the weight of 5.77 liters of oxygen gas at 101 degrees C at 760 torr? We got a gas and nothing's changing, so I know immediately PV equal nRT, 15 points. But how do I get weight? Well, you've got to do this in two steps. First, from PV equal nRT, you'll find the moles. And second, you can go from moles to grams. So what are we trying to get? Grams of oxygen. We're given these values. But first, I have to find the moles. Moles is N. How do I solve for N? I divide both sides by RT. Whatever I do to one side, I have to do the other. I have N equals PV over RT, N equal PV equal RT, but now I have to use the proper units. And here, you're already given liters, and you're given R, but the temperature has to be in Kelvin, so it's in Celsius, degrees C plus 273, that's 101, and that's this number 374 in Kelvin. The pressure, which is given here in torr, has to be in atmospheres. By the way, if you ever forget, look at the units here of R, atmospheres, liters, mole, K. I will give that to you. The important information, it will say and this right here tells you what units P, V, N, and T have to be in. P is pressure, V volume is liters, that's N, and that's your temperature. So if you forget what units, just look at what you'll always have on test of mine or the final, the units of R, and that will tell you what you have to do. Well, I'm giving away all the secrets. So how do you convert at pressure and torr to atmospheres? Use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes underneath. Where do you get these numbers? 1 atmosphere equals 760 torr equals 760 millimeters of mercury. 1 and 760 are exact numbers. Therefore, they play no role. 3 significant 3. And now, in order to find N, PV over RT, P in the right units is this. L, volume has already been given to you in liters. R has been given to you, and temperature in the right units, Kelvin. And we do the math, and we get this to 3 significant figures. And now, if you had, by the way, I did this where I didn't round off at this point. I waited till the very end, and notice you get the same number both ways. Step 1, we have how many moles of O2, but we need grams of O2. So step 2, we go from moles to grams. And here, you have these many moles. You want to go to grams, use your good buddy, your good friend, unit analysis. Whatever you're trying to get to goes on top. Whatever you're trying to get rid of goes underneath. And 3, exact number, and that's the number you have. 5.44 grams of oxygen. And since I made you sit even longer today than normal, I'm going to give you a longer break. Why don't we come back at 11 o'clock? I don't have too much more to do. Quick teaser, and that is after class, for those who want, I will be teaching or giving hints on how to do an outstanding interview. And if you're trying to get into a school like nursing, you're going to be interviewed. If you're trying to get a job and it's anything but pushing a broom, you're going to be interviewed. And therefore, even if you're pushing a broom, I'll bet you're interviewed. Not to say there's anything wrong pushing a broom. But at my level, the interviews are quite extensive. In fact, when I was interviewed, I was flown out to New York to meet with the president of the company, more than 2 different companies what I interviewed for, besides the hiring manager. That's the level I was at. So I know how to interview. I've hired people. After class today, I'll go through. It takes about 10 minutes. It's optional. With that, come back at 11 o'clock. That's when the big hand is on the 12. Or if you have an analog, a digital watch, that's 11:00. I can go stretch. No, that wasn't one of my students calling me, get your class started again. Speaking about getting the class started again, it's time to start again. Welcome back, everybody. Oh, one other thing I think I'll throw in free of charge. I was thinking this morning, what's some of the neat things that's happened because of chemistry and travels. And after I do the how to interview tips, anybody wants to stick around, this definitely won't be in the video. I'll teach you about some interesting things or tell you about interesting things the first time I went to Europe on business. And the first time I was in Europe, or really outside the United States, excluding Canada. And it was, I thought of two stories that I hadn't thought about in years that are quite cute. You might enjoy them. One involves, actually, yeah, one involves the red light district, and the other one involves Al Capone. What? Well, anyways, let's get back to work. Now, remember Dalton's law of partial pressures. When you have a mixture of gases, the total pressure is the sum of all partial pressures. And the partial pressure is the pressure of a gas in a mixture if it were alone. P total equal P1, P2, whatever. Now, a couple things I taught you at this point in this chapter. What's the boiling point of the boiling point of a liquid is when the vapor pressure equals the atmospheric pressure. And what this means is that if you go to different heights on our planet, the higher you go, oh, excuse me, I must have gone too high. But anyways, the higher you go on our planet, the lower the atmospheric pressure, and therefore the lower the boiling point of a liquid is. So if you go to the Himalayas, which was on test number 3, what happens to the boiling point of water? All right, some popular. Another wrong number, 2 more rings, sorry about that. Wow, I hope I should have answered that because maybe they're calling to give me $1 billion. Probably what it is, because if you've noticed, Dr. White is over 65. Is today or tomorrow, or it already has the end date for changing your Medicare coverage, your extra Medicare. By the way, I have Medicare plus the extras with Blue Cross Blue Shield. On that, I don't skimp. I have a colleague who did, and he was sorry he did. So don't skip on things that are important to you, skimp on them. All right. Next, I start talking about solutions. What are solutions? That's a mixture of two chemicals or substances that each one retains its identity. You should know the solvent is the major component or the component of a solution present in, oh, I'm getting choked up over this too, present in the greatest amount. Solute or solutes are all the other component or components in a solution. Next, I talked to you about a colloidal dispersion, and a colloidal dispersion looks like a solution, but it's not, because it's particles of one substance suspended in particles of another substance. And hold on one second. All right, where'd you go? Oh, no. Hang in there. Ah, it disappeared on me. One sec. Ah. Remember, a colloidal dispersion, you haven't seen these at Harbor Freight. They're really amazing little cheap flashlights. And remember, a colloidal dispersion doesn't let light through, even though my hand is not as colloidal dispersion. My blood is, these are neat little flashlights, only $1.97. And they're quite bright, and they even will go on your whatever. And by the way, I don't even get any kickbacks from Harbor Freight. Shucks. And examples of colloidal dispersion: mayonnaise, your blood, latex paint, and milk. All right, next I taught you, and this is very important, like dissolves like. That means like solutes are soluble in like solvents, polar solutes are soluble in polar solvents, and nonpolar solutes are not, are, let's see, polar are soluble in polar, and nonpolar soluble and nonpolar. Mixed two together, polar and nonpolar, they're not. Water, alcohol, salts are polar. Vegetable oil, Vaseline, gasoline, baby oil, grease, and dirt are nonpolar. Oh, it even says know this. Solubility of a solute, the maximum amount of solute that will be dissolved that you can dissolve in a given amount of solvent. You can't put one molecule more or you'll get a precipitate. Saturated solution contains the maximum amount of solute that can be dissolved under the conditions the solution exists. Dilute solution only contains a small amount of solute relative to what you could dissolve. Concentrated solution, a solution that contains a large amount, not the maximum, but a large amount relative that could be dissolved. And this is very important, aqueous solution, that's where water is the solvent, and it's abbreviated by bracket AQ, close bracket. Next, I talked to you about molarity, and molarity, which is designated by a capital M, is equal to moles of solute per 1 liter of solution. And really, it's moles of liter per 1,000 milliliters, because 1 liter equals 1,000 milliliters. In the lab, we measure milliliters, not liters, that often. And I showed you the 2-step and 1-step, and let's see if I can get that open. Hang in there. Nope, wrong thing. Nope, wrong thing. Hang in there. And while I'm looking for this, don't forget 1 mole equals the molecular weight. 1 mole of a compound equals the molecular weight of a compound. All right, everybody see chapter 12 and 13 practice problems? And you can also look at test number 3. Let's look at how many moles of NaCl are in 125 milliliters of a 3.45 capital M NaCl solution. What are we trying to find? Moles of sodium chloride. What are we given? Milliliters. And this number, 3.45 capital M NaCl. What does that mean? Capital M molarity. 3.45 moles of sodium chloride, please pass the NaCl, per 1,000 milliliters. I have to slip that in there at least one more time. And what you're trying to get to goes on top. What you're trying to get rid of goes underneath. And where do we get these numbers? From what this means, 3.45 moles per 1,000 milliliters. This is 3 significant figures. The 1,000 is an exact number. Therefore, milliliters divided by milliliters cancel out. I've left with moles. And now I can very nicely say, all right, do the math, and here's my answer. Now, how many grams of sodium chloride are needed to make 345 milliliters of a 6.789 capital M NaCl solution? We're trying to get grams, we're given milliliters, and we're given this number, 6.789 capital M NaCl, capital M molarity. Molarity means moles per 1,000 milliliters. So 6.789 moles sodium chloride per milliliters. There's no way you go from milliliters to grams. You need 2 steps. First step, you go, and this is given an important information, final exam. First step, you go milliliters to moles. Milliliters, I want to go to moles. I'll get to use my good buddy, my good friend, unit analysis. Whatever I'm trying to get to goes on top. Whatever I'm trying to get rid of goes underneath. Where do I get these numbers? From the molarity, which means this. Remember, 1,000 is an exact number, 3, 4, 3 significant figures. Second step, we're trying to get the grams. We have moles, so we're going to go moles to grams. You have 2.34 moles of sodium chloride. You want to get the grams of sodium chloride. One of the last times this year I can do it. It's time to use your good buddy, your good friend, unit analysis. Love it. And it's just been my good friend and good buddy for, I have to say this, many decades. And what are you trying to get to? Grams go on top. moles go underneath. Where do you get these numbers? 1 mole equals the molecular weight of a compound in grams. The molecular weight of sodium chloride over here is the sum of all atomic weights. Remember, use 3 significant figures for all atomic weights. And therefore, 1 mole, 58.5, 331 is an exact number. And if you round off at the very end, or like I do at each step, you'll get the same number both ways. All right, let's do the very last thing, quick review, since I don't even have a problem set for it, of nuclear chemistry. Everything you wanted to learn in 30 seconds or less. I'll do more than 30 seconds. That's not what I want. Hold on 1 second. All right, 1, there's 2 types of nuclear decay or nuclear reactions. One is fission. I don't know if I'm spelling it right. I think there's only, hold on. You haven't figured out. Dr. White was always the first one down in the spelling bee. And the other one is fusion. This one is large isotope. Small one. It decays plus energy. And here uranium will go to a smaller isotope and give off a lot of energy. Fusion, example of this is nuclear reactor. And you should know this. Fusion, think of the U in fusion as example. The sun, again, the U, that's how Dr. White remembers this. And this is 2 smaller atoms combined to 1 larger one. Plus energy. And on the sun, you have 2 hydrogens making 1 helium plus a ton of energy, which keeps us alive on our planet. Now, one of the most important things I asked you to learn for this was that looks better. The half-life, which is abbreviated by T1 half, and that's the amount of the time it takes for a radioactive element to lose half of its weight or change half. So if I ask you, have 400 grams of lastadium, like today, and it has a half-life of 4 years, then how much lastadium will you have after 8 years? And how do you do this? Well, there's a formula, but for my kind of problems that I do, you have 400 grams and it has a half-life of 4 years. Well, after 4 years, you'll have half of that, 200 grams. And since you're asked after 8 years, well, we'll do another 4 years, which is now 8 total, but you'll have half of this, which would be 100 grams, and that's how you do it. All right, everybody still with me? Test. Anybody still out there? Give me a thumbs up if you can hear me. Test, test, test. Can you guys hear me? With that, I'm done. We've done. I hope I'm not done like somehow everybody hear me now? Am I back? You guys hear me? All right.
Yeah.
Why me on the last day? Well, you think about it, for the whole time, things have gone out pretty smooth. All right. First of all, I'm done for today. I'm done for the semester. Our time together is just about done. One more tea break. Remember the first day of class, I said, my world of chemistry is your world of chemistry. You just don't know about it. Now you do, and you've learned how much fun it is. My world, which is now your world of chemistry. And what I'm going to do is, first of all, say goodbye for the video. And then afterward, I'll give you, for those who want to stick around, which I will cut out of the video, tips on how to interview. And if you still want to stick around, I'll give you 2 cute stories about my first time in Europe, which was long ago when I worked for CHEMI. And the first time I went to Europe, went to Netherlands, and because that's where they were headquartered in the research labs. So with that, first I'll do my goodbye, but I'll stick around and give my advice how to interview. So with that, my final end of the semester goodbye. Game gesund, be healthy. Don't forget the final will be on Tuesday. There are no classes next week, but I will have on Monday office hours. If you need any help or any questions answered, always feel free to email me. With that, bye.